Hello class, sorry I am not able to be with you in class today. Some of you might see me around the school. I'm helping out with some of the admin that were absent today, so they needed some more assistance, so I decided to lend them a hand. So I'm around the school, but I won't be in class today. But to help you out, I recorded today's lesson so you can listen to it, and if you don't get the first time, you can always go through it again and listen to all the information. So we're going to start with your warm-up. So take out your notes packet, and on the front where you have the spaces for your warm-up, I want you to write this down. So the problem for today is write the formula and name for the compound formed by magnesium and nitrogen. So I want you to pause the video, and I want you to take the time to go through, find the charges, balance the charges, and write the formula and name for this compound. So go ahead and pause the video now so that you can do that. Okay, hopefully by now you have worked through this problem and you figured out the formula and name. So let's go through it to make sure you did the work correctly. The first thing you should do is find magnesium and nitrogen on the periodic table. You should have found that magnesium is in group 2. It's one of your alkaline earth metals. So because of that, it's always a 2+ charge. Nitrogen is in group 15. That means it has 5 valence electrons, which means it needs to gain 3 more to complete its octet, which gives it a -3 charge. So if you went through it, you should have had those charges first. The next part you should have done is put them on a balance so that you can balance out those charges. All right, and we can immediately see that our left side's a +2 charge and our right side is a -3 charge, which obviously doesn't balance. So we add to the smaller side first, and we add another Mg. This changes the charge on that side to a +4, which still does not balance with the -3. So now we bounce to the other side, and we add another nitrogen to that side with a -3 charge, and that makes it a -6. Well, now we can kind of see where this is going, because on the left side, all we have to do is add 1 more Mg2+ to turn that into a total of 6. So now your +6 and your -6 cancel. We can bring it all together into a formula, and we can see that we start with the Mg first, and we know that we have 1, 2, 3 of the Mgs. And on the other side, we write our N, and we have 2 of the Ns. So your formula should look something like this. Make sure you have the right number for your subscript, and they're in the little bottom position where subscripts usually go. Now our last part is to actually name this. So we start with Mg. Mg is obviously called magnesium, and you can find that on the periodic table for the spelling or in the top of this warm-up. And then N, which was nitrogen, you have to change the ending to an IDE. So when you do that, you get rid of everything after the R, so it becomes magnesium nitride. All right, hopefully that was a great review of what we did on the last class. Hopefully you finished classwork number 2, which was the first page in the packet that went over all of this information where you're balancing those charges and naming them. Okay, so we're gonna pick up where we left off, and we're actually going to skip ahead in our notes, and we're gonna go to this page. There's no page numbers, but if you look and you see this little Roman guy on a horse, you'll have him on one of your pages. And this is all about transition metals. Okay, so transition metals are those elements in your D block. So once you get to there in your notes, you can pause the video if you need to give yourself some more time, but then you need to copy these notes into your notes packet. Okay, so transition metals often form more than one ion. They're tricky. You can't look at the periodic table and tell what iron's charge will be, because it could be different charges. So when you write the name, you must show the charge of the cation. But how do we do this? Well, we use Roman numerals to show the charge of the cation. Okay, if you haven't finished those notes, you can pause the video so that you can finish them, and then go to the next slide. These are the Roman numerals that you need to know. You probably have learned these before, but as a reminder, 1 is I, 2 is II, 3 is III, 4 is IV, 5 is V, and 6 is VI. 4 is pretty easy to remember. If you remember 5 is the V, 4 is the 1, which is the I, before the 5. So 1 before 5, that's the number 4. For 6, it's the VI, which is a 1 after the 5, which is the number 6 comes after the 5. So hopefully that's a nice little trick, and you can remember the 4, the 5, and the 6 from that. Now this slide here shows you a whole bunch of different a whole bunch of different transition metals and what their charges could be. I don't need you to copy this down into your notes, so don't worry about that. I just want you to see that even if you're looking at something like copper, copper can be a +1 or a +2. It really can change, and it just depends on what the compound is. So there's a whole bunch of examples for you for those elements. Okay. Now let's do our very first example. Okay. Iron 2 oxide. What you need to know is that 2, that Roman numeral 2,
Dylan Forche, please come to the
tells
main
you
office.
the
Dylan
charge
Forche, please come to the main
on the
office.
iron. So that 2, that Roman numeral 2, in between your iron and your oxide, tells you the charge on your iron. So iron's Fe, that means it's a +2 charge. Since it's a metal, it's always a cation. The other part, your oxide ion, is normal. They already named it for you, so you should know the IDE ending means it's an element on your periodic table. So oxide, you look on the periodic table and you're going to find oxygen, which is an O, has 6 valence electrons, which means it has a -2 charge. When we look at balancing their charges, a +2 and a -2 obviously cancel out, so we can stick them together right away and make the compound FeO. Okay, seems pretty easy, right? Okay, let's try another one. Example 2, this one is very similar, but now it's iron 3 oxide instead of just iron 2. Okay, so again, that Roman numeral tells you the charge for the iron. So this time, it's going to be iron with a +3 charge. The oxide part didn't change. That's still your oxygen, which hopefully you know now is a -2 charge. Well, when we look at these charges, they don't cancel, so we have to do some work to make them cancel. Well, if the left sides are positive and the right sides are negative, we have to add more to the negative side, and then we keep bouncing back and forth to make Fe2O3. Okay? Hopefully you drew out your balance and you were able to go back and forth. You should have 2 Fe's to make a 6+, and 3 O's will make a -6. So those charges balance out to make your Fe2O3. Okay, now at this point, I want you to take out your classwork packet that I gave you last class. You should be looking at Unit 3, classwork number 3, balancing charges with transition metals.